Hello, this is John from caveofprogramming.com. In this video we're going to take a look at subtype polymorphism in Kotlin, and we'll also take a look at when expressions. I want to start by creating a little class hierarchy here. We're going to start with a base class which I'll call cat, and that's just going to have one method which I'll call speak. So let's set that equal to print line, and in here I'm going to write I'm a cat. Then let's create a derived class from cat. I'll just copy this to save me some typing, paste it in, and here we'll have house cat, and this says I'm a house cat, and I'm going to make this inherit from cat. To override the speak method here, I have to declare this with override, and then to be able to do that, the speak method in the base class has to be declared as open. Now I want to create a subclass of housecat, so again I'll copy this, paste this in, and here we'll have tabbycat, which is going to be a kind of housecat, and that's going to say I'm a tabbycat. So a tabbycat is a kind of housecat, and a housecat is a kind of cat. It's also true to say that a tabbycat is a kind of cat, because it derives from it via housecat. I don't need to make this class tabbycat open because I'm not deriving any class from tabbycat. I do need to make housecat open because if I don't have that open keyword there, I get an error. In order to be able to derive a class from it, I have to declare it open. However, notice that with this speak method, only the first occurrence of it in the top level base class is declared as open. After that, I don't have to declare it open anymore to be able to override it. For example, it's not declared as open in housecat, and then I can still override it in tabbycat. Only the top level declaration of it in the base class has to be declared with open. After that, it is just open, and we can override it in all derived classes. Now what I'd like to do here is create a program that asks the user to enter some text. And depending on what the user enters, we will either create a cat or a house cat or a tabby cat, and we'll call the speak method from whichever object we create. Now I'm going to create initially an infinite while loop using while true. We're going to use the break keyword in here to stop the loop. Let's first print something telling the user to enter some text. Let's say enter 1 to 3 or 0 to quit. And here I'll put a sort of prompt. Then we'll get input from the user. So val text equals read line, and then we can check the value of text. In fact, I could just call that input to be more clear. Now I want to create a cat variable. So val, I'll call this cat with a lowercase c, and I'm going to make that of type cat. And I want to assign this to a different kind of object depending on what the user enters. We could do this with an if else kind of expression, but we could also instead use a when expression. When is a construct which, like if else if, can be used in a statement form to carry out different actions, or in an expression form to return different values. I'm going to use it in the expression form here. So I'm going to set this variable equal to the return value of when. We have the when keyword, then round brackets, and in those round brackets we have the thing that we want to check, which in this case is going to be our input. Then let's have curly brackets. Now in the case where the user enters 1, here I'm going to return a cat object. Notice I've got error underlining here, and it's telling me that when expressions must be exhaustive. In other words, we must check all possibilities in here, not just one or two of them. Also notice that this is text surrounded by double quotes because the read line function returns text, not numbers, and we haven't converted this input to a number. Let's duplicate this a couple of times. So in the case where the user enters 2, I'm going to create a house cat, and in the case where the user enters 3, I'm going to create a tabby cat. This is still not exhaustive. What we need here is a else clause in the when expression. I'm going to write else. And in this case, I'm going to execute break. The break keyword will terminate this loop. So ordinarily, whatever we write here becomes the return value of when, and these would all have to be compatible types. But in this case, we can execute break because that's not going to assign a value to this variable. It's simply going to immediately break out of the loop without assigning any value to this variable. Notice also that we are allowed to assign an object of type houseCat or of type tabbycat to a variable of type cat. Now this is because of something called subtype polymorphism. Subtype polymorphism is the idea that we are always allowed to use a derived class or a subclass where a superclass type is expected. In this case, we expect perhaps an object of the superclass type of cat, but because of subtype polymorphism, we are allowed to assign an object of any derived class type from cat to this variable. Once we've assigned an object to this variable, we can call the speak method on it. So let's say cat.speak. And again, notice that once we execute break, this is not going to get executed because break will immediately terminate this loop. So let's run this and see if it works. So I'm going to try entering 1, and you can see it says I'm a cat. If I enter 2, it says I'm a house cat. If I enter 3, it says I'm a tabby cat. And if I enter 0, or in fact anything else, including just hitting the return key, which would set input equal to an empty string, it's going to break that loop and quit the program. So you can see that the speak method that gets called is appropriate to the type of object here. In fact, Kotlin can decide at runtime, when the program's actually running, which one of these speak methods to actually call. Kotlin's going to look up the correct method at runtime and call the appropriate method for the object type. So it's actually the object we create that provides the functionality for that method. On the other hand, the variable type is what determines which methods we're allowed to call. For example, if I add a method in houseCat, let's add funGreet and set that equal to, let's say, println hi. And when I say set equal to, I really just mean that we're providing this implementation for this function using this expression function syntax. We can't then call greet using the cat variable. I can't say cat.greet. This cat variable is of type cat, so it only knows about methods that are defined in the cat class. So let's get rid of this because it doesn't work. If I want to add a greet method into houseCat, I'd have to call it via a variable of type houseCat, not of type cat. The variable type decides which methods can be called. It only knows about methods and properties that are defined by that type. The objects decide which implementation of the method in question will actually get run. On the other hand, let's also take a look at extension functions, which, remember, as we've seen, are not true methods. Here I'm going to create a function attached to the cat type, which I'll call greet. And let's implement that by saying println hello from cat. I'll duplicate that a couple of times, and we'll have one of those for houseCat and one for tabbycat. And houseCat is going to say hello from houseCat. Tabbycat is going to say hello from tabbycat. Now let's call cat.greet as well as cat.speak and see what happens. So if I run it, if I enter 1, it says I'm a cat and we get hello from cat, which is what we would expect. If I enter 2, it says I'm a house cat, correctly calling the right method for the object, but it still says hello from cat. It doesn't say hello from house cat. And similarly, if we enter 3, again we get I'm a tabby cat, but it's still hello from cat. Let's quit this. Why is this? Well, extension functions are really attached to variable types, and they don't behave like true methods. We don't get this polymorphic behavior where the right method is called depending on the object type. So here our variable is of type cat, and that means if we call an extension function using this variable, we're always going to get the extension function that we attached to the cat type. So which extension function is called actually does depend on the variable type and not the kind of object that that variable refers to. So here's all the code that we've got today. If you're a little bit lost especially, I recommend practicing this. If you're a beginner, you're going to need practice defining class hierarchies like this. Separately, you might want to try out these when expressions before putting those together with a class hierarchy. And you might want to verify for yourself that in this kind of a situation, indeed the right method gets called, but with extension functions it does depend just on the variable type. This might seem very complicated, but when you practice it, when you type it out yourself and you experiment with it a little bit, it's really going to become a lot clearer. And the thing is to type it out in kind of logical chunks, break this down into its different elements and practice each different element, practice declaring and creating classes and objects, practice the when expression, and so on. So that's it for this video, and until next time, happy coding.